So as part of our analysis enhancements this year, we will be introducing an improved reproduction trait and including this trait in indexes. So this enhancement is going to impact our merino select and maternal breeders who have access to the component reproduction evaluation. And what they will see is they will see this new reproduction trait called weaning rate, and they will see changes and improvements to their indexes. So I'm just going to start by doing a quick recap of our previous reproduction trait, which was number of lambs weaned, or NLW. So NLW was a single trait that was capturing reproductive performance across the entire reproduction cycle. So if we put that into perspective, here we've got two ewes, and they both wean 2 lambs each. So if we're using the NLW model, they actually have the same phenotype for number of lambs weaned. However, when we actually have a look at the pathway that those ewes took to get there, we can see that the first ewe actually gave birth to triplets and lost a lamb, whereas the second ewe gave birth to twins and reared her entire litter. So if we're looking at this from the perspective of lamb loss, that second ewe is actually the more desirable or more efficient ewe reproductively. So number of lambs weaned wasn't doing a good job of capturing these areas of lamb loss. So what we've done is we've developed a new reproduction evaluation. We call it our component evaluation. And what this has done is split that single trait up into its the different components of the reproduction cycle. So we have a conception trait, which is did the ewe conceive? We have our litter size trait, which is how many lambs were born. And then we have our ewe rearing ability trait, which is how successfully did the ewe rear her litter. And these traits have been available for maternal breeders since 2019 and for merino breeders since 2020. We really love this new component evaluation. What it means for breeders is that we can make more targeted genetic gain. You know, if you've identified that you've got good litter size, however, you do want to improve the number of lambs that actually turn up at weaning, you could look at maintaining the litter size trait, however, improving your ewe rearing ability trait. So it allows us to sort of target those specific areas of improvement. From a technical perspective, we're doing a better job of validating your reproduction data. So number of lambs weaned used to look at a joining cohort level. So it was nearly like a tick box. So if you had dry ewes in that joining cohort, it was a tick, you got number of lambs born. If you then had ewes that lambed and lost, it was a tick, you got a number of lambs weaned. In this new evaluation, we're actually validating every individual joining group for variation in the traits, and the same for our lambing groups. So we're actually checking, say, every joining group has variation in conception, so that, so making sure that we have dry ewes in that group, so we can actually evaluate those ewes' performance for conception. What this allows us to do is actually use more data. So if we have a scenario where we have a joining group where we don't have any dry ewes for some reason, however, we have single bearing, twin bearing and triplet bearing ewes in that group, what will happen for those ewes is they won't have a conception record contributing to the reproduction evaluation. However, they will have litter size because they have variation in their litter size. This new evaluation has also allowed us to incorporate genomic information into the trait. So previously, number of lambs weaned, if you were to genotype, it wouldn't contribute or improve the accuracy of that trait. However, now if you were to genotype, it will improve the it will contribute, to these component traits. So we went to the effort of splitting up what was a single trait into its components. However, we then had feedback from industry that, particularly from ram buyers, that having a single combined trait is really useful to help simplify selection for reproduction. And this would also allow us to update our indexes to include these improved traits. So what we've done is we've developed a new combined trait called weaning rate, which is defined as the number of lambs weaned per ewe joined. And this trait is in the same unit as the component traits, so it's expressed as lambs, rather than as a percentage as number of lambs weaned was expressed. And the way that this trait has been derived is that we take into account the economic value or the importance of the component traits at different litter sizes. So if you have a look at that figure on the right of the screen, what you can see is that at different flock litter sizes, so the horizontal axis, the value or the trends that we see in each of our component trait changes. So the economic value on the vertical. So what we can see is that as flock litter size increases, the actual value of increasing our litter size decreases. Our conception plateaus, but our rearing ability becomes increasingly important. So actually weaning those lambs at higher litters is increasingly important. One note is that for seed stock guys, you guys have access to the component trait. So although we've got this weaning rate trait that is helping to simplify selection for our ram buyers, it'll still be important for you to look at those component traits in your selection decisions. So weaning rate is different to number of lambs weaned, although they do technically have the same trait definition of number of lambs weaned per ewe joined. However, weaning rate's been developed using that improved component trait evaluation. So we want to be able to use that improved trait in our selection decisions and in our indexes now. However, to move from weaning rate to NLW, we are going to see changes. So in the table on the screen, what we're looking at is the correlation between number of lambs weaned ASBVs and weaning rate ASBVs for our 2020 drop size in both the maternal and merino select evaluation. And that's indicating to us that we are going to see re-ranking of animals between their number of lambs weaned breeding value and their weaning rate breeding value. So there's a lot of reasons for why weaning rate is different to number of lambs weaned. In our weaning rate evaluation, we have more records than we did for our number of lambs weaned evaluation. And that's because we're using different sources of information for different traits. So as I was saying earlier, we can have ewes that have a litter size record even though they don't have a conception record. This means that we also get more animals with breeding values for weaning rate than we do for number of lambs weaned because there's more records in that evaluation. Therefore, we see more variation in weaning rate than we did in number of lambs weaned. The update of the model has also allowed us to review our correlations between reproduction traits and our other key production traits in our breeding objectives. And all of this is contributing to us getting more genetic trend in weaning rate than number of lambs weaned, which actually better reflects the phenotypic reproduction performance that we've seen from industry. So we want to move towards this improved reproduction trait and using it in our selection decisions. But an important part of that process is also including it in our selection indexes. So what we're looking at here is for our maternal indexes, we're able to swap out or sub in weaning rate for number of lambs weaned. In the table, we're looking at the correlation between the previous indexes, which included number of lambs weaned, and the new indexes, which include weaning rate for different indexes and different cohorts of animals. And what we can see there is we have a very high correlation. So we're not expecting to see a lot of re-ranking in our maternals by including weaning rate in these indexes. What we do see, though, is that we actually see a change in the average index between the previous index and the new index with weaning rate. And one thing that will be important is particularly for those where the average drops, is making sure that we re-benchmark ourselves. So that first line there, we're looking at the BLX index in our border breeders, and we actually see that the average of that cohort go from about 119 down to 112. So when we have new percentiles available for these new indexes, it'll be really important to adjust what we're used to looking at in terms of an average for the industry. We've then gone through the same process for our Merino Select indexes. So we're just looking at our plus indexes here because they are the ones that include NLW in them. For our Merino indexes, it wasn't as simple as doing a straight swap like it was for maternals. We actually had to adjust the emphasis we had on weaning rate when we included it in our indexes. And the reason for that is that we wanted to try and maintain our other trait responses within these indexes, particularly given we'll be looking at having a new set of indexes next year. So it was important to try and mitigate any other impacts on other traits by including this new reproduction trait. So we're looking at the same thing here as what we were looking at for maternals. We've got our correlation between the previous index, which included NLW, and the new one that includes weaning rate. You can see there that for the DP plus or the dual purpose plus index, the correlation is slightly lower. That is just because the DP plus index has the largest, or reproduction has the largest contribution to that index of the three. So therefore, by changing the reproduction trait, we're most impacting that index. We then also have our averages for the index when it included NLW compared to when it includes weaning rate. We don't see the same magnitude of change in average as we did for maternals. However, it will still be important for our Merino breeders to have a look at the new percentile bands when they're available. So in summary, we've got two changes coming in terms of reproduction that will impact our Merino and maternal breeders. The first is that we will be replacing NLW with a weaning rate trait. This means that NLW will no longer be reported and that the reproduction trait that's available will be weaning rate. We will also be updating in any indexes that include reproduction in them from the trait being NLW to weaning rate. This will cause changes in indexes because we know that weaning rate is a different trait to NLW. So it will just be important for breeders to re-benchmark themselves when new percentiles are available.